All right. So this is 3.5 homework. Once again, I get these are off. You'll just have to get over it. All right. So now we're going to look at imaginary numbers. In the other video, I've covered a lot of this. This is more going to focus on, once again, the homework. So let's go to some of the difficult problems. I want to look at 4 just to kind of get us started. So the square root of negative 44. I don't know if I explained it in the video this way, but here's what you want to do. Anytime you see a negative under a square root, the easy thing to do is go ahead and take that out and just say that means I goes on the outside, because square root of negative 1 is I. So the easy way to do this is I see negative under the radical, I replace it with I, and then I make this number positive. Then all I have to do is break down what's in the radical, and I'm finished. So I'm just going to keep I on the outside. So I stays out here. I want 2 factors that give me 44. One of those needs to be the biggest perfect square that's a factor of 44, and that would be 4 and 11. So now I keep I on the outside. I can take the square root of 4, which is 2, but now that jumps to the outside. Since I'm taking it out of the radical, now it goes to the outside with I. So I have 2I and then radical 11, and then I'm finished. All right. So anytime you do this part where you break something down and take it out of the square root, it goes to the outside and it's multiplied. Because if you notice, these two numbers are side by side. That means that this is multiplication. So like, let's say this happened. Let's say we had a 2 already out on the outside and we took out a radical 4 and we took out a 2 out here. That would mean that our problem was 4 radical 11, because we would multiply these two right here. All right, so that's kind of the quick version of that. Let's go to another one. So going a little bit more complex would be looking at number 8, because number 8 and 7 actually we have two radicals multiplied together now. So here's what we're going to do. We're going to do 8, but you would do 7 the exact same way. Here's the first thing you want to do. All these negatives under this radical, we want to take all 3 of those out. We want to take those out of the radical, and then I goes on the outside. So I actually have I times radical 6, I times radical 12, and then I radical 5. Because here's what we're going to do. We're going to multiply these in 3 different spots. Well, 3 different spots, but 2 different ways. First, everything on the outside multiplies together. So we're going to multiply I times I times I, which is I to the 3rd power. All right. Then we're going to multiply everything in the radical, but we're going to keep it under the radical. That's how you multiply radicals. So like first, we can just do this to the left. Radical 6 times radical 12. You multiply these 2 numbers, but keep it under a radical. So like that would be radical, let's see, 12 times 6 is 72. So that's a quick example of that. Now, when we multiply 3 radicals, nothing changes. We just multiply all 3. So we say 6 times 12 times 5, and that gives me 360, I believe. Yeah. So we have I squared radical 360. So now what we're going to do is break this part down, and we're also going to break what's on the inside of the radical down as well. Now, I squared is negative 1. So technically, I to the 3rd, if you remember to break these down, we can break that down into I squared times I, because then we can replace this with negative 1 times I. So this would just actually be negative I. All right. Then we can break down 360 with 36 and 10. So let's write that out. All right. So the square root of 36, square root of which, let's do this. Let's move it over here. So the square root of 36 times the square root of 10, that's going to give me a 6, and that 6 will go to the outside. So now I have this times 6 radical 10, and here's how it looks all together. It would be negative 6i radical 10. Let me double check. And yes, that is the answer. So remember, anything you take out of a radical, make sure you multiply by what's already outside of the radical. And in this case, the 6 would just multiply and give us negative 6i. All right. Also, we're going to look at this next, but you're going to really have to practice this I to the third power and I to the different powers. It's always good to try to break it down into terms of I squared. That way you can replace that with negative 1. In this case, the only way we could do this is I squared times I to the first, because when I do my rules of exponents, I would multiply this back, add the exponents, and get back to I to the third. So we're really just expanding that out. And then we can replace I squared with negative 1. And then in this case, negative 1 times I is just negative I. All right. So now let's go to the two I was talking about what we were going to do. So 9 and 10. I want to do these with you just because these are difficult. All right. So we have I to the 28th. What you want to do is divide this number by 2. If you can divide that number by 2, here's what you can do. I can say I squared in parentheses, because we know that is really just negative 1. So if I can put I squared in parentheses, here's what I can do. I can raise it to the power of 28, except I used I squared in parentheses. So what I can do is say 28 divided by 2. That would give me, let's see, 14. Yeah. So now I can raise this to the 14th power. All right. Now, you can always do that with even numbers. Notice that 28 is even. All right. Now, you'll see on number 10, 49, obviously, is not even. So we'll look at how to do that. There's an easy way to do it, but it just takes practice. All right, so let's get back here. So now, we just said I squared is actually negative 1. Now I bring down my exponent 14, and then you just really have to remember this. Any even exponent means that your negative becomes positive. So you can say negative goes to positive. Any odd means that you would see the negative stay negative. So, which is not negative 1. I don't know what I'm writing. All right. So now, the negative 1 to the 14th right here just would become positive 1, and that is my answer. All right, now let's look at 10, because we just said 10, 49 is not an even number. What that means is if we tried to take 49 and divide it by 2 and make I squared, we just wouldn't be able to do it unless we do this. We need to break this apart and make it I to the 48th times I. Because what we do is we take out one of these i's that's an exponent, we put it over here, but we need to always make sure we can go in reverse and get back to I to the 49th. And in this case, if we took this and multiplied it, we would add the exponents. There's an understood exponent of 1 right here, so we would get back here to 49. Now, what we can do is we can take the 49 and we can do the same thing we did with number 9. We can say, okay, I know that I can change this to I squared, and I'll end up with negative 1. But to do that, I need to make this 48. I need to divide it by 2, and that will give me 24. Because now if I go in reverse, if I multiply I squared, well, if I take I squared to the power of 24, I would multiply them and get right back to I 48, or I of I to the 48th power. There we go. All right. So now this portion just keeps getting brought down because you'll see what we'll do with it in a second. So that's just going to stay as I. Now, I'm going to replace this with -1, the I squared, because it's always -1, to the 24th times I. Now, this portion, I can just say 24 is an even number. If this is negative, then it's going to become positive. So that's just going to become 1 times I, which means the answer is I. Now, it's going to take you a little bit to get used to those, but maybe it helps me showing you 9 and 10 from the homework. If not, then I don't know. It's not going to be a major deal, but we do need to make sure we can do a little bit of this. So let's keep going. Let's go to number 13. So on number 13, this is going to be a big one that you'll have to be able to do. It's going to incorporate rules of exponents, and it's also going to look at a few more of the I problems. All right. So now, notice that we have two things being multiplied. So obviously we're going to multiply. But before we do that, we have an exponent of 3, and rules of exponent or order of operation says do the exponents first. So notice that this does not say, this does not have a plus or a minus in between 4 and I. If it were to look like this, like -4 plus I, we would have to do this a totally different way. We would basically have to multiply this by itself 3 different times. But when there's no plus or minus, you don't care about that. So when there's no plus or minus, you can take this exponent 3 and you can just apply it to this -4 and I. Okay? So technically this would look like this. -4 to the third times I to the third. All right? So then -4 to the third power would be -64. And it would stay negative because 3 is an odd number. All right, times I to the third times 2I, which now we really don't need this times portion here. We can just say -64I to the third times 2I. Now's where we have to remember our rules for exponents. When you take two variables or two letters and you multiply them, you actually add the exponents. But we still have to multiply -62 times 2 first. Those just get multiplied like normal numbers, so we don't really have to change anything, or there's no rules for that. Now, my I for the first term, or the first, first I has 3. This one has an understood 1, so technically that's to the 4th. All right, now I to the 4th, we could say is -1. Because, well, we could break this down a few different ways. If you want to just remember this, you can. I to the 4th is just 1. I don't know. It may help you. It may not. If we don't know that, we would have to do this. We would have to say, rewrite this as I squared. So then that means we divide the 4 by 2 to get the exponent on the outside. So that's -1 squared, which equals 1. So this is really just -128 left once we do all of that, because these two are multiplied, so it would just be 1, which wouldn't change anything. All right. Another thing you can do, though, I to the 4th is always 1. That's a good one to memorize. -1, these are the two that you really want to remember. I squared equals -1. I to the 4th equals 1. Those are good ones to know. All right, so now let's move on and let's go to the back. So on the back, you're solving the equations. Now, you're going to probably solve all of these by square roots. So if you want to write that, you can say square roots. Okay, so you're going to see something's going to happen. We're basically going to end up with negatives under our square roots, and we just have to account for that. So let's go to 17. All right, so on 17, we have x squared and no other x. That means you have two options, difference of squares or square roots. So when you see this and no other x, that means you have two options, difference of squares or square roots. All right, so we're going to use square roots. So we need to subtract 71. subtract 71, because we need to isolate x squared. So then 2x squared equals, that would be negative 234. Once again, if we want to use square roots, we have to isolate x squared. So we're not factoring here, we're just isolating x squared and using square roots. So x squared equals negative 117. Now you'll see where the issue comes up. To get rid of this exponent 2, we square root both sides. Now we're taking the square root of a negative number. You just have to notice that. But first, let's bring in our plus or minus. Square root negative 117. Now you can see we're doing the square root of a negative number. Anytime you see that, go ahead and take it out. Take it out and replace it with I. So we actually have plus or minus I radical 117. Now we need to break down 117. So we could say, I'll write it up here again just so we have it. Radical 117. All right. We can say, if I could write, that would be amazing. All right, there we go. That's better. All right. So now we can say, okay, I know that this can break down into two factors, and one of those factors needs to be the biggest perfect square that is a factor of 117, and that would be 9. So that gives me 13 as the other factor. So here's what I have. I have x equal to plus or minus. Now, I can take out this radical 9, and it is just 3. So when I move that 3 to the outside, there's also an I out there, and they're multiplied, so they just sit together. So then this is my final answer. My final answer is x equals plus or minus, positive and negative, 3i radical 13. All right. Hopefully that one helps you. I think pretty much all the rest of these work very similar. So yeah, you'll just have to practice these, and then once I'm back, I can answer any questions, but hopefully that helps a little bit. Actually, real quick, let's just do one more. Let's do number 20 just so you can see. All right, so once again, you see x squared, you think two things. You think factor or difference of squares, or you think square roots. And we're going to use square roots. All right, so now here's what that means. I want to isolate x squared. So I need to get rid of minus 15 by adding 15. Then I need to get rid of this negative, but we'll do that in a minute. Well, actually, this negative 4 over 3, but we'll do that in a minute. All right, so negative 4 over 3, x squared equals, that would be 216. All right, then to get rid of this negative 4 over 3, I multiply by the reciprocal. So you have to remember to do that. The reciprocal would be negative 3 over 4. And we do that on both sides. Okay, now x squared equals, let's see, that would end up being negative 162. All right, now to get rid of this exponent 2, we need to square root each side. X is going to equal plus or minus radical negative 162. All right, now this is where you need to go ahead at the beginning and take out the radical. So we'll move it over here. So we're going to take out the negative out of the radical. All right, so let's see. X equals plus or minus I radical 162. Now we can break down 162 into two factors that give me 162. When I multiply them, we need one to be the biggest perfect square, and that would be 9. Well, 81, so 9. So that means I have, this is going to come out and give me 9. I have 9 radical 2, but I have to remember I had something on the outside already, so it gets multiplied by this 9. So x is equal to plus or minus 9I radical 2. All right, so we did an extra one. You're welcome. Hopefully that makes sense, but if it doesn't, just try to help each other out until I get back. But that's the end for this video.